All right, this is Unit 2.3, displaying quantitative data with graphs. So our goal today is to be able to classify types of quantitative variables and represent that data graphically. So we started that last time with dot plots. That was our first graph that we described quantitative data. And so I put this on our misleading graphs day just because I thought it fit since we'd already done one of those before. Today we're going to look at another way to describe quantitative data, and we're going to talk about how to describe it and then go into stem plots as well. So when we look at describing quantitative data, there's 4 characteristics that we want to look into, and that is shape, outliers, center, and spread. So if any question says, describe the distribution, okay, if we are asked to describe the distribution, we have to address all 4 of these things. On AP and College Now exams, I've seen where they will ask us to describe the distribution, and they're looking for 3 out of the 4, because maybe there's not an outlier, or maybe they're going to ask us to compare one distribution to another, similar to what we did with the cities that Brian and Jessica were looking at and the temperatures that they had. So shape is the skew, the peaks, the valleys, the clusters, the gaps, the tails, anything that has to do with like the visual shape of the distribution. Outliers are observations that fall outside of the pattern. They're extreme and they're unusual. And so we're going to have rules to identify these ones that are extreme, but sometimes our first idea is by seeing the shape and we can visually even see outliers. Then we're going to come up with rules later that'll help us algebraically identify these outliers as well. The center of the graph, this is going to be our midpoint, our 50-50 marker, the median, or the average, which would be the mean. Even though centers are sometimes lumped in as mean, median, and mode, mode just tells us the one that occurs most often. It might not actually be a center of the data. Then spread is the amount of variation of the values. Maybe max to minimum, which would be our range, maybe middle 50%. So if we did the middle 50%, that would be our IQR. There are going to be things that we can describe the spread. How far apart are our data values? Are they consistent around a certain center? Are they inconsistent with a lot of variation? So these are some of the words and things that we want to use when we describe a quantitative data set that says describe the distribution. We want to think SOCs. So for the first thing, looking at describing by the shape. So if I want to describe the shape by the skew or by the mode, these are the 2 ways that we would describe it. The first one would be we have symmetrical, where it's not perfectly symmetric, but we would say, yeah, this is about the same amount on each side of kind of our center value. And then we have skewed left and skewed right. So if we say this is tail on the left, where the tail is, this is tail on the right, and that's why it's right skewed. I also think of like my left foot would have my big toe here, and it kind of leads off down here, where this is my left foot, and then my right foot would look this way, where I would have my foot here. And again, super awesome artist here. Oh my gosh, I can't even draw this way. Okay, maybe those feet don't even go together, but this is how I remembered it when I was in AP Stats. Nope, I was in Miss Fast Room when I took it with Mr. Millard back in 2002. But here it's out. So anyways, the skew of this distribution can tell us about the distribution. So if I know that it's tail on the left, then it tells me that I have more data here on the higher end with some data points on the left. Skew to the right side of the data is longer than the other side. So this is going to stretch out to the right side. Uniform would mean it's about the same everywhere. Even if there was 1 dot above, I would still say that's a pretty uniform distribution, that it's not symmetrical around a peak and it's not skewed one way or the other. The other way we can describe the shape is by mode. And mode is the value that occurs most frequently. And this is going to be our peaks. And so unimodal is where we have one peak. Bimodal is where we would have two peaks. And then multimodal just means we have lots. And that's where our data is going up and down. And this is where we would say there's not a lot of consistency in overall data, but maybe we have 3 clusters of data is where we could start describing that distribution. So if we looked at the data that we did on our previous section, the 2004 women's soccer team, and these are the number of goals they scored in each game. So I've just copied that over here from the last time. Can we describe this shape by skew and by mode? So by skew, we would describe this, okay? I would have here kind of like this overall. I would say skew, this is likely to be skewed right. There's more goals at the lower end and it's stretching out to the right to get to that 8. As far as mode, okay, this would maybe be, I would even come down and go back up where we discussed having there's 2 peaks here. One that's happening on number 1 and the second one that's happening on goals that were scored 3 times in a game. So I would call this bimodal. So I would describe the shape as it's skewed right and bimodal. If we wanted to bring in the context here, we would say the data seems to be skewed right, which means there are fewer games where there were lots of goals scored. Their distribution is bimodal, where we had lots of goals that, or lots of games that had 1 goal scored and lots of games that had 3 goals scored. Bringing in that context is part of statistics. If you just say skewed right bimodal, we haven't really addressed this distribution in particular. It says describe the shape of the distribution of goals, not just this empty, unknown data. This is about something. So anytime we describe socks, we want to make sure that we are doing it all in context. As much as we can bring context in, we want to make sure we're doing that. The second way that we can describe and display a quantitative data set is using a stem and leaf plot, also called a stem plot. So dot plot is the first way we can describe data quantitatively. This is our second way. And so I describe this one as like a sideways dot plot that breaks up the digits of the values of the variable. So a dot plot is for a small data set that doesn't have a lot of variation. This is going to be a similar idea, but maybe we have larger numbers here. So when we look at this, we have a stem and leaf plot here, stem plot, where we have our stem here, and this is our numbers that are going to be 0, 1, 2, 3, 4, and 5, and this is not going to skip anything. So even if I didn't have anything that went in the 1 column, I would still use that as part of my stem. And then this side is the leaves. And together they make a number. 0, 6, this would make 12, this number would be 39. So I always read this number with this number. And each one of these, again, we can see the individuals of every single one. Make sure that you include a key anytime that we're making a display that is a stem plot. So don't forget the key. That is one of the ways that people lose points on College Now and AP exams is if we're asked to create a stem plot, make sure you're explaining what each one represents. So they're telling us this key says 2, 5 means 25. If I had another key, I could have said, 2, 5 could be 2.5. Another key could have possibly been 2, 5, and it could have been 2,500, where they've round up to the nearest hundreds here. We want to make sure that we're communicating our data well to somebody that's looking at our display. So on our first example here, it says a random sample of 20 teenage girls at a school were asked how many pairs of shoes do they own. Okay, so again, we might have some response bias here where they're misremembering things, but this is just to their best of ability here. So if this is the data that we've collected, can we create a stem plot of the data? So I've created these stems looking at the data where we have our lowest value is 12 and our highest value was, 57 here. So the stems I created were 1, 2, 3, 4, and 5, and then we can record it. So I would have 50, 12, 26, 50, 26, 13, 31, 34, 57, 23, 19, 20, 19, 30, thank you, 24, 49, 22, 13, 23, 15, 38, and 51. So this was my quick data set. But what we have to look at is the order here. These are not in the correct order. So I might write those down and go, okay, it's supposed to be 2, 3, 3, 5, 9. And then I would change that and go, okay, erase that and put those in order. So the first time I did it, I just wrote them down in their columns, and now I'm going through and changing it so that they go in order. So either in my head, I'm going to say that in my, recreate the order in the numeric order, or write it down somewhere really quick so you can copy it over so that this goes in the correct numerical value order here. So 2, 3, 3, 4, 6, 6, 0, 1, 4, 8. This one I didn't really have to change, and then we needed to change the 7 and the 1 there. And so if I looked at 4, 9, right now I haven't made a key. So this is asking us, essentially, what is that key? What would 4, 9 mean? So 49 pairs of shoes owned by a teenage girl. That brings in the context too. B says, circle the data point that shows a female student reported owning 31 shoes. So I would go to my stem that's 30, and 1 would represent 31 pairs of shoes. So that's what I did over here, circling that data point. Our second example is dividing each stem into 2 or more stems, because maybe there's too many individuals on one line or more stems. So like here, when it starts getting longer and longer and longer and longer, or maybe we had a data set that was just looking at 2 things, we can split that up to better see the distribution. That's going to be, if we have a larger data set, we still want to see the individuals, a split stem will help us do that. So 0 to 1, these 2 are getting quite long, and so we can start to see that skew here, but maybe it's more pronounced, or maybe it's more symmetrical if we spread the data out a little bit. So anytime we split them, each one of these gets split in the middle. So any of these ending in 0 to 4 goes on the front end, the top end, and then 5 through 9 through each one. So we don't 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We don't split it here. We split it consistently for each one and say, okay, 0 to 4 goes here, 0 to 4 goes here, 0 to 4 goes here. So when we look at this, creating the same, this is a different, now these are teenage boys at the same school. Now we would create the split stem for the boys that would be here, where they already have it in order. So I'm going to copy over 1, 3, 3, 4, and then split it 6, 6, 7, 7, 7, 8, and do the same thing for 0, 0, 2, and then 5 through 9 would go here. 2 would stay here with nothing at 25 and above, nothing at 30 to 34, 5 would be my next one. And I would get this as my new split stem with a key that maybe I would say 0, 1 is 1 pair of shoes owned by a teenage boy. My dad definitely was this way. He bought 1 pair of shoes and he was like, they are good for everything. He might have like a flip-flop pair, but he would wear them forever until they would be done. Like he's no longer using them anymore. My grandpa does the same thing, but then they transition to mowing shoes. So he wears the same pair of shoes the entire year forever. And then once they get bad, then he throws out his old mowing shoes and now those shoes become his mowing shoes and he gets a new pair. But they're always the exact same. I don't know how to do it. I am a shoe person, so I have lots of different shoes. Even though I don't often change, I don't wear them all, but I like buying them. That's a habit. I have to fix it. So if we put this 2 together, maybe I wanted to compare the girls and the boys together. This is our last one where now we have a back-to-back where I can compare them not on just one or create one for girls and one for boys. I can make one entire distribution. So a stem plot with 2 categories, still of the individuals whose data points are shown, and now they're on either side of the stem. So this is called back-to-back, where the boys and the girls' stems are the same. So I've split the stem here, but now boys' data will come out to the right and girls' data will come backwards out through the left. And so this would be allowing us to compare them. So I can bring down the boys. Oops. Without skipping a number here. And so just like on a dot plot, we want the first, second, third, fourth, and so on observations to line up on those columns so that we can also look at this almost like a bar graph as well. And then we had 35 and 38, okay? And then for girls, we didn't have our first one until we went here. And again, I'm going backwards because it goes stem out. So on this other side, I'm going the 5 and 9 because I'm splitting up my data. And then I had 6 and 6 here. 0, 1, 4, 8, nothing, and 40 to 44, 49, 0, 0, 1. So this might feel a little backwards, but that's because it goes stem out. So this is a stem plot. My key for this one, I would say we have to keep it the same for both sides. So my 3, 8 is 38 pairs of shoes. And so the key is always read to the right. So 3, 8 would be stem and going out. So that's always what we represent our key with. So if I want to describe the difference in response trends for the girls and boys, I still want to describe the distribution. I should still be thinking socks here. So putting that together, I would talk about, maybe I would say the average number of shoes is lower than the average number of shoes for girls. I can see that the boys are lower, or I can see that the girls are higher, either way. But I want to bring in that context, make sure that we know we're talking about not just this distribution as numbers, but as the number of shoes. And so this would address the centers. Okay, if I continued, I could say there's a wider range of shoes for girls than boys. So these go from 1 to 50 and these go from 0 to 30. So this has like a 40 range and this has a 30. So maybe I could address the spread here by looking at that, and I could say There is a wider range, or there's more variation. That's another way to say wider range of shoes for girls than boys. And so now I've talked about these two. I could say these are potentially outliers, and doesn't appear to have any outliers in the girls. So I could maybe say the boys with 35 and 38 pairs appear to be outliers. Where the girls are more consistent. And again, maybe we have some concerns about this 57, but I would need to look to see if that's really different algebraically. Visually, it doesn't look that far off from 50, 50, and 51. And so now we've addressed these three, and the last one would be shape. So if we looked at shape, this one, okay, if I turn my head so that I have the lower numbers here and the higher numbers here, this would be skewed right. Boys' shoes are skewed right. And then if I turn my head the other way, I kind of want to think of this like, or I guess not turn my head the other way, because if I did, that would put 50 at the bottom, and 50 is not where we start counting. We want to think of this like if it fell down, what would it look like? So it would have 3, 2, 4. I would still say this is pretty, right skewed as well. What didn't mean to add that. So maybe I say boys and girls are skewed right. So that would imply that for both of these groups, there's more data at the lower end than there is at the higher end. That the tail is reaching up to the right there, to the higher values. All right, so our goal today was to be able to create stem plots, whether it was a split stem or back-to-back, making sure that we don't forget the key, as well as learning about describing our distributions with socks. So shape, outlier, center, and spread. Anytime we have describe a distribution, we want to be addressing those things. When we're describing two, we want to use those comparisons. Is lower, is wider, appears to be outliers, are more consistent, are both the same. Bring in the context, bring in those comparisons. Don't just do socks for the girls and socks for the boys when they asked us to describe the difference in them, or to describe the similarities even as well. So on your homework tonight, let's practice those. And if you have any questions, let me know.